Hello, Peter. You can start.
So, may I?
Yes, please.
Okay, good evening, good afternoon, good morning, wherever you are. This is a global, colloquium, so we are in different time zones. So my greetings to everyone, and this is our season finale. Like I just mentioned, that this is last colloquium, I mean, the last speech that we have for this season, and I'm very happy to have you all here. And let me just briefly introduce this colloquium to you all. The Data Analytics Colloquium, we shorted as DAC, is supported by NCHU, where I'm at right now, and UT Dallas, the EPPS school, and then Dr. Carl Ho and myself, we're co-host this colloquium. And I want to thank you and welcome you to today's speech. We've invited Dr. Chris Achen and Harold Clarke, Harold Clarke as well. And so this colloquium is sponsored by both university. So this is the second season, and we're looking forward to more seasons to come. And this colloquium, we try to invite all the various distinguished professors in the methodology, especially the political science area of political science. So I think all of you here are very excited um, to join this colloquium and listen to the two professors and what they have to say about today's the topics. And Dr. Achen is going to present first, and then Dr. Clarke is going to join the conversation afterwards. Okay, and thank you, Professor Ho.
Thank you. Thank you, Dr. Penn, and thank you. Now, allow me to introduce Dr. Achen and Professor Chris Achen is the professor Roger Williams Strauss Chair of Social Sciences at Princeton University. His primary research interests are public opinion, elections, and realities of democratic politics. And he has a long list of publications and awards. So to highlight a few, and he's published 6 books, including the one well-cited Democracy for Realists with Larry Bartels. And this book has won 2 international awards. And also this is a subject of a special edition critical review, and then also was reviewed in Foreign Affairs. And multiple book reviews and The Economist, New York Reviews books, and elsewhere. And he also is well known for his being the author and also co-editor of the book titled The Taiwan Voter, 2017. The book convenes a lot of famous studies and well-cited studies and on Taiwan elections and Taiwan politics. And I believe today this is one of the most comprehensive book on Taiwan elections. And he is the co-author, is a co-editor with T.Y. Wen, and of course he authored some chapters in the book. And he's also well known for being a founding president of the Political Methodology Society, and he also received the first Career Achievement Award from the Political Methodology section of APSA, and he actually made it first in many accolades, and he's also well known for among one of the best teachers in Princeton. He was getting awards from the University of Michigan and Princeton, and he's much appreciated by many of his students, who already are famous professors, well-cited professors in universities all over the world, and not just in U.S., in many other Asian countries too. Now today he's going to give a talk on the topic getting the politics right in election research, and he'll be joined by Professor Harold Clarke to discuss this topic too. Without further ado, allow me to introduce Professor Chris Achen, Princeton University. Thank you, Chris.
Thank you so much, Carl, for that gracious introduction, and thank you, Peter, for co-hosting today. Can everybody hear me okay and see the screen?
We cannot see the screen yet. and it's black. And can you try that one more time?
I will try it one more time.
It worked before.
Yeah, it did work before. Let me try it again. Is it there?
There we go.
Yes.
Okay.
There we go.
All
right, good.
Thank you.
I'm more used to Zoom, so I apologize for my slowness in getting this going today. I have too many slides today, so Carl, please just give me a heads up when I talk too long, and I'll stop. I want to try to convey the overview of this stuff, but not get lost in the weeds. So I'll do my best on that, and you
Don't
can
worry. Yeah.
You can just speed me up when I get too slow.
Yeah, the night is still young.
So, so, but I want to start with my general thoughts about political methodology here. It is hard work to learn statistical methods. It takes all of us some years, and understanding politics is equally hard. And what political methodologists try to do is to do both things at the same time, and that's even harder than doing either one of them separately. I think it's just very important to have our statistical models represent the politics of what we're talking about, and that's not easy. Too often we just take a model off the shelf and we don't worry about it. We dump explanatory variables into it, and we make all kinds of linearity assumptions that may not make any sense. So to give a Taiwan example, suppose we just add a dummy variable for being a mainlander or a Hakka into a regression or a Probit or something like that. That assumes that Hakka people are exactly the same as Minnan people, but that they just differ in their intercept term in the statistical specification. Well, maybe. So we need to think. Sometimes that's okay, but other times we may need to add interaction terms to make the statistical model right. In other words, Hakka people don't respond to some variable in the same way that other people do in Taiwan. Other times we may need to divide the data and analyze different groups separately. People don't like to do this because it reduces sample size, but sometimes different groups are so different that there's no real choice on that. One of my former African-American colleagues said to me once, "I hate dummy variables for race." And what he meant by that was a dummy variable for being black says black people are just like white people, but they have a different intercept term. And that's just plain false. And then lastly, more often than we might like, there may be no familiar statistical model that we were taught or that we run into that matches our substantive understanding of politics. An example of that is turnout and vote choice, which is my focus here this evening here and tomorrow for those of you in Taiwan. Studies of elections almost always analyze vote choice and turnout separately. People who study turnout just study turnout. They mostly don't talk about vote choice, and the same is true for people who study vote choice. But this doesn't make any sense, right? Trump, Franklin Roosevelt, Hitler, other people all raised turnout. On the other hand, a dull election like Taiwan's 2016 presidential election had low turnout. So what that tells you is that, let me get this little thing off my screen. There you go. That choice and turnout go together. They are endogenously related. That's not news to anybody listening to this talk, but we tend not to do anything about it. So instead, we do logit and probit for vote choice, for example. But that's not adequate. Even in a two-party situation like the United States, we have a few tiny, tiny little third parties, but they don't amount to anything. We need three alternatives, one for each of the two parties plus abstention. And of course, in multi-party systems, we need even more. So ordinary probit or logit do not get the politics right in election research. They leave out turnout if they're about vote choice, and they leave out vote choice if they're about politics. So in case there are graduate students who are just beginning their study of English and I'm talking too fast, I have a little summary of what I've said so far there that Professor T.Y. Wong, my co-editor on the Taiwan Voter, prepared for me for today. Okay. Now, sophisticated people who study elections, and particularly elections in multi-party systems, they use multinomial logit. And there's a fair amount of that in the literature. The problem with MNL, multinomial logit, is that it assumes independence of irrelevant alternatives. So what does that assumption mean in an election? It means that if James Soong had not run in 2000 for the presidency in Taiwan, Chen Shui-bian's margin against Lien Zhan would be unchanged. Chen Shui-bian would have won anyway, even if Soong hadn't been on the ballot. Well, that's not likely, right? Soong and Lien are both KMT, but in any case, that's not what you want to assume in advance. You want your statistical method to tell you whether that's true or false, not assume away the problem. Now, you might say this is crazy. Why is anybody using multinomial logit? There's again a summary for
I found I'm a little rusted in reading Chinese now. You should give me the English version of abstract too.
So why haven't we given up on multinomial logit? Well, particularly because there's something out there, multinomial probit, MNP, that does not assume IIA. I have IAA, but I meant IIA. Everybody agrees statistically that this is the best method, and it allows for correlation among alternatives. So it would not assume that James Soong's presence on the ballot in 2000 was irrelevant to who won. It would allow for the possibility that having Soong on the ballot split the KMT vote. Sounds great, but nobody uses it. There were some elaborate experiments 2 decades ago. They're just a handful of papers, but it hasn't been used much since. Why not? Well, for example, some of the early models, it took 10 hours to get one set of estimates. And then 2/3 of the time, it didn't converge at all. And so it's just kind of oddly set up. Parameter identification seemed complicated. Interpreting it seemed complicated. So people just don't use it. And they go back to multinomial logit and they put in a footnote that says, I know I'm assuming independence of irrelevant alternatives, but it's probably not hurting me too much. There's no evidence of that, but that's what they do because it's just too hard. So, for instance, early on, it was so hard to program the estimator that nobody ever used survey weights. And of course, survey weights, especially nowadays where a lot of people don't respond to surveys, survey weights are crucial. There is literally not a single estimate anywhere in print for election data using multinomial Probit and also using survey weights. I am going to show you one. It is the world's first. People just haven't been able to do it. It's been too hard. We argue that the problems with MNP have now largely been overcome. And what we've been working on, this was our APSA paper originally, and we've been working this fall. It's a little bit of hard work, but we think we can produce rules to make it easy for people to use it. So that's the last part of the abstract, and tells you what the rest of the paper will be, the presentation will be about. Okay. Now, one of the oddities, please just interrupt me if I'm incoherent or say stupid things, or you just have a question. I'm happy to be interrupted. I can't see anything except my screen right now, so please just speak up.
Sure.
One of the oddities of this literature is that MNP was developed for transportation studies, mostly by Dan McFadden, now a Nobel Prize winner at Berkeley. So they did models of going by train or going by car or going by bus or bicycle or walking or whatever. So the whole literature is written in terms of how that field works, transportation studies. And it's presented that way, it's programmed that way, and when people working on it have used MNP, they thought they had to do it the way transportation people did it, which looked strange sometimes. But we believe that political science problems are different, and that MNP can be presented in a way that works for us political scientists. There's a lot of stuff in the transportation literature. There's subtle issues of various kinds. We think that those mostly don't cause political scientists any real problems. And mostly we can go ahead, as we always have. But excuse me, to make it work, we do have to think more seriously about the politics. And in particular, we're finding that if you ignore the group foundations of elections, you just think in terms of issues and policy positions and so forth, it doesn't work very well. So it is the argument that Larry Bartels and I made, and many dozens of other people have made, that elections are fundamentally about groups, and that's the way to structure the thing. So we'll say more about that in our forthcoming paper when we have it more tacked down. So I'm not going to go into the technical arguments much here. I'm just going to show you some results from the 2016 American presidential election study done by the Pew Foundation here in Washington. Why Pew? Well, because they validated turnout. Validating turnout is an expensive business, but they have the money to do it. And they didn't do it by a computer program the way ANES did. That just turned out not to work very well. They did it in the old-fashioned way. They looked up the voting records and the voter files and validated it that way. So they have much less over-report than most studies. Over-report, remember, is the tendency of people to say that they voted when they really didn't. And Pew has a few percentage points of that, but it's not bad. It's much better than everybody else. By contrast, other important studies of the election have over 90% turnout, and the real number is in the low 60s. So, you just have to take a study that has enough non-voters in it to get the right answer. So this is Donald Trump versus Hillary Clinton, as you all remember. We use survey weights And we've also studied the 2017 South Korean presidential election, but I'll only discuss that very, very briefly today. Now, MNP is an extension of Probit. And we usually justify both of them by a utility model. So the scale of utilities, these are cardinal utilities, the scale is arbitrary. And so only differences matter. So a linear transformation of the utilities leaves everything unchanged. So we have to do some things to set the scale. And that's true in Probit and in multinomial Probit. So we have explanatory variables that we're familiar with from using Probit, and they give they explain differences in utility between one alternative and another base alternative. So, for example, if you're just using vote choice, you're not paying any attention to the people who didn't vote, and you're looking at Trump versus Clinton. Trump is the choice alternative and Clinton is the base alternative. So the model here is that there is an underlying utility that I'm calling V. We would ordinarily subscript that with an I to indicate which respondent we're talking about, but I skipped that here. So this underlying utility is the difference between the utility for Trump and the utility for Clinton. And you've all seen this when you studied Probit. We assume that that difference is a linear function of explanatory variables. So in the case of a single explanatory variable, we write V is equal to A plus BX plus U. So a linear function of X. That's the underlying utility that we're assuming. Now, we take U to be independently normally distributed. Now, we don't observe that utility difference. We just assume that it exists, and that if the utility of voting for Trump is greater than the utility of voting for Clinton, then the voter chooses Trump. Otherwise, she votes for Clinton. Then the estimation routine just chooses values of A and B to maximize the fit to the observed choices. So you've seen all this before. What I want to direct your attention to is interpretation of the coefficients. Now, suppose we find that an increase in education predicts a vote for Clinton. It does, in fact. What does that mean? That could be because education raises the utility of voting for Clinton. That is to say, more educated people like Clinton. Or because more educated people don't like Trump. They're maybe don't care either way about Clinton, but they don't like Trump. We don't know which one of those it is. In fact, it's worse than that, because it could also be that low education reduces white turnout, and that whites with low education prefer Trump, which we know they do. So in that case, the low education people wouldn't show up at the polls, and that would help Clinton, right? So that would raise the vote for Clinton. So education would predict the Clinton vote, even though education had no effect on preference, right? It's all turnout, could be all turnout. And again, we just don't know which of these it is. And we just ignore it. And we just ignore all of it. And we say education predicts the Clinton vote. But all those underlying questions are there all the time. And they occur in multinomial Probit also, where we have to deal with them more explicitly. I just want to remind you that they are not new. We're always talking about differences in utility when we use Probit or Logit. And those differences, unfortunately, mush together both preference and turnout effects. So same setup in MNP, but we have more alternatives, and we can separate preference and turnout. Again, the citizen just chooses the highest alternative. We choose one alternative as the base, and here we'll use abstain as the base. And we have to make some changes in how we set up our models to get it to work well and make it politically meaningful. Again, Juan Ho and I are working on that and we've made some progress. We're not all the way done yet, so I won't say too much yet, but I'll just say that in July, our models didn't converge a lot of the time, and now they always converge. So we're getting better, but we still have some work to do. Here, I'm just going to show this very briefly. Here is the underlying math for the multinomial Probit case. What I want to direct your attention to there is equation 4, which gives the variance covariance matrix of the disturbance terms of the residuals, if you like. So we've got 3 alternatives: Trump, Clinton, and abstention. We have explanatory variables for all 3 of them. We have a disturbance term, the stuff that we're not measuring. Those disturbance terms are correlated, and that's the general form of the correlation matrix. Now, at the bottom of the page, we convert to differences. So this is differences from, the Republican from the Democrat, and the abstention minus the Democrat, if you want to do it with that way, or you can take the differences from abstain, as we usually do. In any case, we have differences. So that generates new disturbance terms, just 2 of them. And the resulting matrix is 2 by 2, not 3 by 3, because it's only the differences that we can really talk about. So the big problem that the literature talks a lot about is, how do you get from these 3 numbers here back to the full variance covariance matrix? And that's where all the technical problems occur. I won't say any more about that for right now, but I just wanted to alert you to what's going on. So what I'm going to show you now are coefficients for Trump and for Clinton relative to abstention. So they answer this question. When a citizen is comparing the utility of voting for Trump versus not voting, which variables influence that decision? And the same for Clinton. It's a little different from the way we ordinarily think about it, but it's important to see that we have to do something like this if we want to separate vote choice from effects on abstention. And that difference, say the difference of Trump versus abstention, a variable can affect that either because it improves the utility of voting for Trump, or because it reduces the value of abstention. So we've already seen this in the Probit case. Here it is again, and it's just those differences that we're trying to explain. So here are some examples from our estimates from the Pew Foundation 2016 survey. Other coefficients weren't very different, but these are a little bit. So let me just give a couple of examples so you can see what's going on. So take, for example, the effect of education. Here is the effect of education on Trump versus abstention. And here is the effect of education on Clinton versus abstention. Why are these both positive? They're both positive because education raises turnout, right? So it raises turnout for the people who want to vote for Trump. It also raises turnout for the people who want to vote for Clinton. But it doesn't raise them by equal amounts. It raises them by, this difference. They're different by that amount. The reason is educated people like Clinton better than Trump. So we're seeing a separation here of the benefit Trump gets from education and the benefit Clinton gets from abstention, from education, and those 2 numbers are different. Here's another instance. So Black turnout, African American turnout in this election was bad. Black people liked Clinton, but they didn't vote. So they went out this way because they liked her, And then they got pulled back because they tended to abstain. And so they wound up at a kind of a zero effect. With Trump, on the other hand, they didn't like him and they abstained. And so he winds up with a negative coefficient and so forth. So what we're seeing here is just the ability of multinomial Probit to separate these different effects. By contrast, in ordinary Probit, as we've seen, we're just looking at, in that case, people who voted, and that can make a difference. So we're still exploring what kinds of situations, what kinds of elections are the ones where multinomial Probit is particularly valuable. We want to compare it to multinomial logit and to multinomial Probit with uncorrelated errors, with, in other words, making the IIA assumption with MNP. It's easier to use, but as we say, I have said already, those are there are assumptions there that we don't like. So the question is, when does it make a difference? And we want to talk about that. So here's some estimates from an earlier model that show you what's going on here. So this column is ordinary Probit, same election, ordinary Probit, voters only. In other words, people who didn't vote, you throw them away. That's what we usually do. Here is the equivalent of multinomial logit. It's multinomial Probit with uncorrelated errors. That's the kind of thing most people do. There's a paper about a recent Taiwan election that uses MNP with uncorrelated errors. And then here's the real multinomial Probit that allows for correlated errors. Notice that income has a big effect in these two standard things that we do, but it doesn't have any effect in MNP. In fact, the coefficient estimate is slightly negative. What's going on? Well, income has two effects here. One is that this is in the is in the Trump direction, and in both of those first two, we think, well, higher income predicts voting for Trump. That sounds normal. Rich people want to vote for the Republican, so it's all about preferences. But actually, we have the vote preferences for all respondents in this survey, including non-voters. So we can actually find out what the population as a whole thought about Trump and whether that's related to income. And the answer is no. The relationship is flat. Rich people tend to be better educated, so they were no more enthusiastic about Trump than were poor people who are mostly white and liked Trump because he was, in their minds, he was defending white people. So it's actually flat. And MNP finds that. It's the correct answer. So why are the standard things that we do so wrong? The answer is that lower income people who favored Trump voted less, right? They were less inclined to go to the polls. They're the kind of people who aren't very engaged. Other low income people are actually more engaged than the Trump voters. So among voters, higher income predicts a Trump vote because the lower income Trump people didn't get to the polls, right? But that's not about preferences. There is no relationship of income to preferences. It's a finding about turnout, right? And by our ordinary methods, we would get that wrong. Only multinomial Probit gets the right answer. And similar results occur for interest in the campaign, where only multinomial Probit gets the coefficient, the sign of the coefficient correct. Korean presidential election in 2017, some of you may remember, was followed on impeachment of the president.
Mm-hmm.
I'll just give you a quick look. This is work that Won Ho did. Here, on the effect of income in ordinary Probit for voters only is positive, but it's negative and substantial with the equivalent of multinomial logit, and it's less negative, but still negative for MNP with correlated errors. So not all the coefficients are different, but a fair number are, and we just think it makes sense to check it. So how can we see the effect of a variable in an election with multinomial Probit? This is a little tricky, right? So a variable might raise the utility for a candidate, might have a positive effect on that candidate's utility. But if it raises the utility of another candidate even more, right, then the vote for the first candidate will go down. So we really need some help, and we that turns out to be pretty easy to do. So here again is another slide. It's the effect of education on the vote according to multinomial Probit. And there it is. I actually did this at dinner time tonight. So I thought we should have an example of this. So this is education down here. It's coded on a 0 to 1 scale. So these are people who didn't finish high school. These are people with postgraduate degrees, and these are intermediate categories. And you can see that the effect of education on the probability that somebody will vote for Clinton is quite substantial and quite steep. And by contrast, it drops for Trump somewhat. Again, less educated people loved him, but lots of rich people voted for him too. So it's a little bit flat. And then here's the effect on education, on abstention. And you can see that drops quite substantially with education, which we know from the literature. So as education rises, two things are going on, and two big things are going on, and one little thing. The big things that are going on are that people like Clinton more, and that turnout is falling. So they like Trump less, but he doesn't drop as much as you might think because turnout is abstention is dropping also. So he manages to hang in there. And it's relatively easy to do these plots and to get onto a probability scale instead of a Probit scale.
Mhm.
So, summary. MNP has become a workable estimator. That just hasn't been true. And we think now that it is. You have to know some things. You need a little advice. We have figured a lot of that out. We have a little more to do, but it's now workable. And we think it makes a difference. And it clears up mistakes that come from what we usually do with Probit logit and multinomial logit. We think that our results for the presidential elections that I've shown you illustrate this point. That said, however, there is work to do. We got things wrong the first month or two, both numerical convergence issues and errors of political interpretation. And that's the kind of thing people have run into before. We now have good software. We use Stata because it makes survey weights so much easier. This model can be done in R also, although we haven't seen yet how to do it with survey weights in R, but in any case, both R and Stata have software, and it's just getting easier. However, dumping variables into it just doesn't work, and we learned that by doing dumb things the first month. You really have to pay attention to the politics. In the case of the Korean election, for example, there are 3 candidates: Moon, Ong, and then a guy named Ahn, A-H-N in English. And Ahn is a kind of, he's like Ross Perot from the early 90s and mid 90s in the United States, for those of you old enough to remember Ross Perot. Ahn is kind of a wild card, and he's not particularly tied to either party. And he appeals to people who have no party identification, just like Perot did. You have to know that, and you have to set up multinomial Probit in a way that takes account of that. Otherwise, it doesn't work. So it puts pressure on your political understanding, but we think that's okay. So there's work left to do. We will have a revised paper by spring, where we hope to have kind of concrete advice about how to do this in a way that makes things work smoothly and avoids some of the struggles that we had the first month or two doing this. We thought this paper would be quick and easy. It has not turned out to be that. We've come to understand why nobody has done this for 20 years, but we think that times have changed, and that we can. The models now converge every time, which they weren't at the beginning, and they run in a minute or so. So we think we've gotten past the hard part. We've stopped using the transportation literature setups, which again they were standard in all the papers from 20 years ago. We've gotten away from that and tied the necessary constraints to political understanding. And so we think we've gotten past the worst of it. But I just wanted to give tonight and morning for those of you in Taiwan, give you a little sense of how progress is being made, and tell you that we have something on the way that should make it easy for those of you who want to use MMP to apply it. Okay, that's it.
Great. I think, can you all hear me? Okay, good. Now, I think this is very illuminating. I think I call it illuminating. This is opened my eyes about the problem of multinomial logic, which has been basically ubiquitous, and everybody uses MNL and in election research at Taiwan. US maybe less often, because we have usually 2-candidate race, and you have a 3-candidate race in other elections could be using multinomial logic. In the Asian case and Asian election case, and we use that a lot too. And I think the British case, and we see a lot of three or more candidate races in elections, and at this point, allow me to introduce Dr. Clarke and to shed light, or maybe give a few point of discussions. And Dr. Clarke.
Thank you, Carl, and thank you, Chris. Very, very interesting talk as usual. And so I have a few thoughts that occur to me, probably more than a few, but I'll try to just confine myself to not too many here. One of the things that I'm certainly old enough as Chris is. We have got a fairly long history with doing these kinds of models, and but to begin with, I think one of the fundamental points politically here is this idea of bringing turnout in as one of our choices. And as Chris rightly pointed out, this is very seldom done. We did this in the British case in a book that we published in 2009 in Chapter 7 of that book, Performance Politics and the British Voter. But it's not something you see very often even today. And I think in terms of the politics of the situation, it's certainly something that we want to pay attention to. And Chris's example with education, which he mentioned, and showed us the graph of the margins probabilities at the end, towards the end of his talk, I think shows us that it really makes a difference it can make a difference in terms of interpretation of what's really going on with some of our predictor variables that are very popular candidates that we employ in our research. And so I think that's an important takeaway in terms of just what kinds of choices are we considering, and certainly bringing turnout into the game is something that's well worthwhile. So I certainly commend that idea. Second thing, and related to that, of course, and Chris rightly mentioned, that turnout is one of the really poorly measured variables in most election studies and in most survey research. And the amount of error in terms of it's typically over-reporting, as Chris mentioned. In fact, I can't think of a single case where we've had under-reporting in all the surveys that we have done. But the amount of over-reporting varies from varies across survey modes. It's actually, at least in the American and British case, it's actually better with the old-fashioned face-to-face surveys, and it's worse, considerably worse, with internet surveys, and it's absolutely horrendous with telephone surveys. So that is something to keep in mind, that we're going to have, if we're going to bring turnout into our game, then getting hold of data such as Chris has with the validated vote, which we have done with our British studies as well, and has been done, of course, in various milieus. That can be a very important thing in terms not to have really gross mismeasurement of one of our key categories. Now that said, there are studies out there that say that in terms of the kinds of stylized facts that we come away with, it really doesn't matter if we use reported turnout or validated turnout. I tend to be a little skeptical about that, but nevertheless, that's something that in terms of a research agenda, I think there's still some good work to be done. Of course, when we want to model turnout as part of our in our ambit of choices, that can expand our list of covariates quite substantially. In fact, we called our model amongst ourselves, the investigators, we were doing our work, bringing turnout, and we called it the big flat model. And it was flat because it didn't didn't have turnout before preference choices, but it was big because we ended up with an awful lot of covariates. The turnout scholars, of course, have a variety of rival models, and investigating those adequately is going to expand your list of covariates quite substantially, at least potentially. So, there's some challenges there in terms of trying to keep some control in terms of using theory to really try to corral what we're doing. In terms of statistical models, this has been a presentation that has heavily emphasized the multinomial Probit model, which some of us were introduced to, as Chris said, a couple of decades ago. But there are other models that will be interesting to us as well, particularly the mixed logit model, which is one that I've used quite a bit. And I know Carl Ho has used it as well. My former award-winning PhD student, I'm pleased to say. And the mixed logit model is an interesting model. It will accommodate this IIA concern that Chris underlined in his talk, but it also makes a very nice distinction between the characteristics of choices and the characteristics of choosers. And with regard to the characteristics of choices, we're able to actually think of those parameters as being not fixed, but as random parameters. and we can actually have a variety of distributional assumptions. For example, where it might be, all theory tells us there's no way that we could go to the negative side of the real line with a parameter, then we can consider using things like a log normal or perhaps a Bible or something like this. So that's an alternative model I would draw to the attention of the group that you might want to look at. In terms of random utility, just thinking about that for a moment, over the last decade, a number of people, mainly in Europe, have started working with what we call random regret-based discrete choice models, and there's quite a number of studies now, or a sort of burgeoning literature is emerging. And in fact, for those of you who like to use Stata, the new version of Stata, Stata 17, actually will allow you to do the random regret models, which of course, in terms of the assumptions that are being made, it's a different kind of model, and it's one that may behoove you, that you may find again interesting theoretically, and it's now, like as Chris said, some of these models we knew about before, but we really weren't able to estimate them for a variety of reasons. But this again has become a practical, like the random Probit model, or the Probit model that Chris is talking about. The random regret model is now something that's a practical alternative. And for example, in the British case, we with the famous 2016 referendum on Brexit, there's been a lot of discussion afterwards about what they call B regret, people regretting the choice they made. And so in cases, of course, that was a dichotomous choice, and it really doesn't make much difference whether you're doing an RUM or a random regret model. You're going to come to the same place. But when you've got 3 or more choices, you're really into a different world with these models theoretically. And so, again, that's something I would draw your attention to. So that, on the statistical side, there's good news in terms of software. Of course, there's also very good news in terms of the kind of hardware that we have, and things that used to other things being equal take 10 hours may now only take 10 minutes or something like this, because we've got such good computing power. And so again, this is something that makes the suggestions that are in Chris's talk, something that we can really think about as a feasible alternative. In terms of one of the things early in the talk, I won't go on much longer here at this point. But early in the talk, one of the really interesting things Chris mentioned was this idea that sometimes groups are just so different that we want to analyze them separately, and we might the traditional way of putting in a series of dummy variables and so on just won't do the trick in terms of providing the information that will give us valuable ability to really interpret what's going on in a valuable and valid way. Another thing, though, that I would mention along this line, and we've been doing a little bit of this ourselves, sometimes with some few data, with some other data as well that we've been gathering, is the use of what we call what are called finite mixture models. Some in the audience may be familiar with, and particularly in an era of polarization such as we have not only in the United States, but we certainly see in our British case and elsewhere as well. Less so in Canada, I might say, but still some there. This idea of investigating the idea of multiple processes in your data is a really interesting one. And the finite mixture model allows you to do that, to estimate how many people are in each of your groups, typically no more than 3, but often just 2, and certainly in the American case, that can be quite valuable. And you can also parameterize the probability of being in each of these groups. And of course, the American case, variables like some of the demographic variables like race, ethnicity, perhaps gender, and certainly partisanship would be candidates to be covariates for that part of the model. So again, when it's really sort of an exciting time. I guess I'd conclude by at this point. There's we're able to do things that we couldn't do before for various practical reasons, but there are also some theoretical advances being made that make this a really sort of exciting time if you are a political scientist modeling voting, modeling voting behavior or other kinds of choices. And so, let me stop with that at this point, and turn the floor back over to you, Carl, and Peter as well.
Yeah, thank you, Dr. Clarke and Dr. Achen. This is really a great illustration of application of a new model. It's not new method, but it's still generally new methods, how we can apply that. And Chris really did a great job in giving this illustration. Then let us know in the past we may have done something wrong, but we still believe that this is what everybody is doing, and but we look closer. This is much more we are missing if we do not take into account another option or another alternative that we take for granted. That option is in one of the categories, and so in the Taiwan case, in the American case, and now I'm particularly interested also in the FMM model that Dr. Clarke also mentioned too. And then I will come back to that with more questions with Dr. Clarke about FMM and also the random regret minimization model. And but let me open to the floor, or to your audience. If you are if you have any questions, please either speak up or you can type your question or raise your hand, and to ask questions for either Dr. Achen or Dr. Clarke. And before while we are waiting for questions to come up, I have a question, maybe a series of questions for Chris. So Chris, now compared to multinomial logit and multinomial probit, and multinomial probit that did take into account the alternative that we used to ignore, right? So when we interpret the result, I think you made it second column in one of the tables, and so when you assume that there's the errors uncorrelated, and then we can do the comparison. But actually, the second column in one of the tables suggests that this is not much difference, or how much that could be, what kind of differences also you can find in terms of the key variables such as political parties or issues, and because those are the main variable of interest when it comes to evaluating the probability of supporting one of the candidates, or in your new model findings, how much those key variables contributed to the probability of abstention. Is it Chris? Yeah.
Yeah. I'm only seeing Harold on my screen.
Okay. Because you are still sharing your screen, I think.
Oh, okay.
It's a screen inside the screen.
Okay, I have stopped sharing. Let me turn my camera
then we
on
can
and
see
your. Okay, now I'm back.
There we are.
Yes,
there we are.
Thank you. I'm just not used to this platform. I'm a Zoom person. I think the honest answer to your question, Carl, is we just don't have enough experience with different data sets and different circumstances now to have a feel for the kinds of variables that are the most sensitive to the differences among these estimators. I was honored to have Harold talk about this presentation because he has so much experience with data from around the world, notably Britain. We certainly cite him not just in this paper, but in other things I've written, and that kind of experience is exactly what we'll need to have with with MNP in different circumstances to get a sense of when it really matters and when it doesn't, and we're just not, I think, just not there yet. But I think step one is to get the thing running in a convenient way. So we just haven't had that. It's just been an incredible pain. Even the transportation people complain that the thing doesn't work half the time. So I think that's really our goal here. And then we'll quickly learn, not just from what Wan Ho and I write, but from other people's experience, how this compares with these other estimators that Harold mentioned, which we reviewed briefly in our paper. There are quite a few options, different ways to do this. It's still the case that MNP is the most general, so it's got that appeal going for it. But the other things are serious estimators too, and I just think we need more experience to sort out which ones are going to be helpful in the long run.
Then, can you give a little bit more, maybe, in your experience when you compare the NMP with extension and uncorrelated error? Is that basically just the same as MML, multinomial logit, or similar to that?
Yeah, in both cases, what those models assume is that the errors are uncorrelated. Multinomial logit assumes that, and
there's no IA in attention.
Yeah, so it's just like the difference between Probit and logit. The Probit scale is bigger. So my rule of thumb is multiply the logit coefficient by 3/5, and you get approximately the Probit coefficient. It's just almost the same model. And that's true in the multinomial logit and multinomial uncorrelated errors Probit case as well. They're just very closely related.
Yeah, but in terms of standard errors, this should be comparable. It's pretty similar, though. Yeah. Do you have any? We have a hand here, and let me. Glenn has a question. Glenn, please go ahead.
Hello, thank you all very much for the presentation. It was very interesting. Dr. Achen, I have read Democracy for Realists, and I found it an excellent book, and I would highly recommend it to everyone on the call. Although I did find it a little depressing for us. For us democracy faithful, right? But yes. it was a very good book. My question about the MMP. So it looks like the analysis that you have been doing focuses on understanding the past. And I'm just wondering if you see the model as a potential for predicting future outcomes and what you might think in that regard.
Thanks for the kind remarks about that book, Glenn. It was a little depressing to write also, but we felt that the truth was the truth. Larry Bartels at Vanderbilt has a colleague who says that when he read the last page, he closed the book and thought about committing suicide. So We weren't
But he's
quite,
still alive.
Thankfully, I didn't go that far.
yeah, we didn't either. But anyway, it is a bleak book in some ways, but that seemed to us what the data said. Anyway, thank you for the kind remarks. With respect to prediction, it's a tough business. So where are you located? Are you in the States?
Yes.
So
Texas. I'm at UTD.
Oh, okay, great. So that Donald Trump may run again. If I asked you to predict whether he would win, I believe neither you nor I would have the data we would really need to answer that question with any reliability. I like to think that the right statistical model helps, but it's like predicting which new car model will be successful, and people spend millions of dollars on that and they get it wrong. So I think there's a hard problem here of knowing how ordinary people are going to be thinking 3 years from now. And so I'm a skeptic on forecasting. As you know very well, we use the state of the economy as our most reliable forecast up until the last month when the polls start to be reliable. But before that, state of the economy, well, ask an economist what the economy will be in 3 years, and economists don't know for sure. So I think you've asked a really hard problem. I think we're just not there yet.
Wonder if I could I add a point, Carl, on this? One of the things we need to keep in mind when we're doing this kind of work is that we're studying individual voting behavior, and we're not studying election outcomes. And certainly the 2016 election dramatically underscores the importance of keeping those two ideas in mind, because of course Trump was close to 3 million votes less than Hillary Clinton in 2016. And if you look at what he did, he traversed an incredibly narrow path through the Electoral College, which enabled him to win. Now, in 2020, by the same token, he lost by about 10 million votes, I think, this time. But again, if you actually look at what he might have accomplished, he had a very narrow window even before COVID came along, and he would have actually had to do pretty much what he did in 2016. And we have argued in a couple of papers we published recently that basically COVID cut that path off. But the fundamental point, keep in mind, I think Glenn and other people, is that there's this gap. It's a pretty sizable gap in some countries like the U.S. between studying individual voting behavior and studying election outcomes. And to be sure, the former, informs the latter, but they're not the same thing.
Yeah, Julie has a remark, and she said for Trump can add divine intervention and religion as new variable. Yeah, I think she was. I hope there could be something empirically doable.
I'm a churchgoer myself, and I'm not above asking for divine intervention. I hope we get some.
But I also like to chime in for example, going back to Chris' suggestion. So it depends on the alternatives. Now that when we think about this question, if Trump is going to run again, and so what are the alternatives? Now, of course, then we need to know if Biden is going to run again. Now, the other one is, I think this is something we want to want to pay real attention to what Chris suggests. So you're betting against the chance of not turning out to vote too. So if you ignore that, then the idea is the model could be off. The model could be off, and if we ignore that option, so that will complicate the equation. Of course, if you have three candidate race or multi-party or multiple seat and in a multiple single district or multiple seat and etc., then that will make it more difficult to, particularly in the PR system and PR setup. And so I think that is why your study here will shed light on maybe bringing a new way or a new fashion of seeing these models to be evaluated or re-evaluated, and that is something I think if we pay more attention to this, and we can see that this is a high value for application and for replications in other areas, a more extended research in election studies and etc. Now we have let me pass the mic to the Taiwan side to see any questions, any students would like to poke a question to Chris or Harold. Peter?
Yes. Well, I try to just integrate all these questions here. All right, to start with, to me, I think personally, I think this is a great lesson learned. Great lesson learned, because it's quite encouraging for the past 20 years, and then people haven't done that, and then this is the start that where we start to use the MPN. So it's encouraging that the computational capacity today can support use. All right, so and then about election study, I think we have a question here because Glenn mentioned about prediction, and then here's a question about which of the above mentioned models are better suited to incorporate the intertemporal issues. For example, election study. You know, we're trying to, well, people are observing or very curious about. People are doing the opinion polls all the time, and then it happens that we observe the preference or utility, you might call it, change over a relatively short period of time, say less than a few months, as the opinion polls show. So like the question says, the intertemporal issues. How do you, which of the above mentioned models, including Dr. Clarke mentioned models, can better suited to to tackle or to solve these issues? And also, I have the other comment that we all it's practical to think about a prediction in this election. It's a big thing, but we've been talking about more about the structural variables such as sex, education, race, etc. But in terms of prediction, there are too many other variables that we cannot incorporate into our model. So the study here is maybe it's more stable structural variables we are working on. But in terms of prediction, there are more other maybe some issues and some policy issues, and things come up as you unexpected. So that's why the prediction is difficult, right? But what we can do is try to put in or incorporate more structure variables and try to make the model as comprehensive as possible, if I may use that word. So that's probably it's some comment and questions. Maybe Chris or Harold, you can give us some recommendations or answers. Thank you.
Chris?
I'll start, and then I'll answer the easy ones and hand off the hard ones to Harold. The easiest one, first of all, I'm sympathetic to those remarks from the students there. In particular, I'm sympathetic to the question about the importance of looking at choices over time. So there is a version of multinomial Probit and other things as well, but it's particularly suited to this issue. And there is a version that allows for a little bit of panel structure, so maybe 2 time periods. And so the idea of a single time period, as I talked about today, and as probably most or all of you are familiar with, you have a set of alternatives and you pick one at a single time period. That's how choice models work. And once you have a panel of the same people, then you've got a choice at the first period among a set of alternatives, and then another choice at the second period. So you're making 2 choices. Statistically speaking, this blows up the problem in a challenging way. So, you know, the likelihood function in the single case requires numerical integration over, let's say, if you have Trump, Clinton, and abstention, take differences, you've got a 2-dimensional error structure. You've got to integrate over a 2-dimensional normal curve to get the likelihood function. Once you have a panel with 2 time periods, you have 2 of those at each time period. So now you're integrating over a 4-dimensional normal distribution, and that's a lot slower and harder. So it's challenging. What Juan Ho Park and I want to do for next APSA is look at that case actually, and it looks it looks doable, but that's in a manageable amount of time. That's what we thought last September with that paper. It turned out to be pretty demanding, so we'll see how this next one goes. But it's certainly the case that whoever asked that question asked a very important question, and one that we want to try to address. Harold, I'll hand off.
Okay, no, I think that's a great question, and this idea of looking across, you know, even a two wave panel across successive, say, presidential elections. I think that's really interesting. And it actually takes us, if we can make this work, if people like Chris and his colleague can make this doable, is really important, because it helps take us down the road with regard to the problem that I mentioned earlier of this distinction between individual voting behavior and election outcomes. Because for any particular election, you have people exiting, for example, we're talking about turnout, who exit from the active electorate, but then we have others who are entering the active electorate as well. So to be able to bring all of that into the framework of a single choice model would be really cool. And that would be very nice. So I wish you good luck with that, Chris. And that's a really interesting thing. We must not, though, make the mistake of assuming that 4 years ago is T-1 in terms of any sort of political psychology. It just happens to be when we gathered the data. This is one of the real problems, not just with individual level panel data, but with time series analysis as well. What we call T-1 typically is just something, a matter of convenience. It doesn't necessarily correspond at all closely with the kind of decision making that's going on inside the mind of the voter. So that's sort of a footnote, if you will, to this. But the idea of doing these at least two-way panel is really a very interesting one. And as I say, takes us down the road to get us closer to articulating voting behavior with election outcomes.
I'll just add very briefly there that we don't have a good study of the 2018 midterms, that Democratic sweep. And that was an incredibly important election. And so it's the 2018 midterm is T-1 for the 2020 presidential election, but we don't have it, as Harold said. We have 2016, so that's really T-2.
Okay, thank you. Carl, you.
All right. And any more questions from Dallas side? And actually, I want to add a footnote to that, and particularly on the issue effects. And I think that can bring us to a bigger picture, looking at the issues. For example, and I'm thinking about now here using COVID. So COVID may have different impact on different candidates. So say incumbent may be subject to more impact of COVID because the voters will take this incumbent accountable for the COVID, and but the challenger may be they be more lenient on him or her because they may not know any records of this challenger, this candidate contesting that the incumbent. So I think one way of doing that, one way of MMP can do better is also incorporating this kind of probability or this kind of impact specific to the alternatives. So it will be really interesting, and bringing Peter's suggestions that to study this individual issue impacts on the alternatives, plus how much these impacts this could prompt. For example, some voters or some new voters never voted, but getting really upset about COVID situation, then they will turn from a non-voter to a voter. Then they maybe vent or something on the sentiments on the incumbent. So that could be a really interesting comparison, and to see the issue impact and how much that differentiate. We have differentiated impact on supporting each of these options, including the extension. So I think that MMP could be a really ideal candidate to incorporate this kind of issue impact in the equation model, right? Yeah.
Yeah, absolutely. I'll also mention here for the Taiwan people that at elections in Taiwan now, the voter has 2 votes, one for the local representative and another one for the list.
Party list, yeah.
Yeah, and of course that's true in places like Germany as well.
Yeah.
From the viewpoint of a statistical model, that's a panel, right? It's 2 choices by the same person from the same set of alternatives, but with different considerations at the 2 elections. So again, I haven't seen this studied in the Taiwan case that way, but I think it's and I'm not going to do it, but maybe somebody listening to this conversation might, and I think it's a nice opportunity.
Good suggestion, yeah. Dr. Clarke, what do you think?
I think it's a marvelous research suggestion. I know Guy Whitten, who some of you know at Texas A&M, and I did a little work on this with a German election study that we had about a decade ago. But there, I'm not familiar with that much work. Some of the people in Scotland who are studying the elections to the Scottish Parliament have been working along these lines too. But there's still a lot of good work to be done, especially with some of these new statistical models or invigorated statistical models, such as we're talking about this evening. So I'd certainly, again, make it a research, suggestion. Another one I had, though, that was, I thought, and Chris may already have done this, or one of his students had, or colleagues, is I'm thinking in terms of, what the economists call stylized facts. And we say, okay, well, we know that we're doing something probably very likely wrong, quote unquote, when we're using multinomial logit. But I wonder, I think it would still be interesting to take a look at using simulations, just how often do we really draw a different sort of stylized fact? Oh, party identification was really important, or education worked this way. Do we really get, how often do we get different results? Now, that's mainly retrospective in my mind because of what Chris said this evening. We're now at a position where we don't have to make a bad choice. We can at least make a better choice using techniques like MNP or perhaps mixed logit as opposed to traditional multinomial logit. But I'd still be interested. I think it would be a great project, for a dissertation or a master's thesis to do some simulations, some serious simulation work, and just see to what extent we draw qualitatively different inferences from our data, assuming we've got the same theory. We're working hard on our theory in both cases. We're setting up our model with all the relevant choices and so on. To what extent do we really, get it wrong, quote unquote, with the traditional approach? So I was just going to suggest that. Again, we have some students here. I think that would be a really cool thing to do.
Yeah, I couldn't agree more. There's no point in using elaborate, complicated estimators if they don't get you anything, if they don't solve a real problem that the data present. So that definitely, we're going to do more on that, and we hope other people do too.
Yeah, another example that I could just mention recently is this challenge to the conventional random utility model that's been opposed by the random regret models. The random regret models are, as I said earlier, have some attractive theoretical features to me, especially given the kinds of things that Chris and Larry talk about in their book that we mentioned earlier. But if you look at comparisons that people have been doing, again, the stylized facts look a lot alike in many cases from the two statistically, theoretically different approaches. So, that's always a question: is what's sort of the practical payoff that we get from using a more complex estimator? But as Chris says, on the other hand, now we can do it. So why worry going forward? So. But there's a tremendous literature out there, and it would really be nice to know just to what extent we have been off track with it.
Mm-hmm. Okay, Peter, do you have any questions from the Taiwan side?
Yeah, just a short question, and we are some students there, the master graduate students, and then so we're interested to know. Well, here's the question. The election study is one field that obviously can benefit from this MNP. And could you, professors, give us some example that MNP is used in modeling policy issues? Just some example that would be very helpful. Thank you.
It's primarily designed to explain individual choices, and you need at least 1,000 observations to make it work adequately. So to use it to model, let's say, municipal decisions about how to fund their sewer systems or something like that, it probably isn't going to work very well because you won't have enough municipalities with the relevant data. But there are other kinds of choice situations that people face throughout the social sciences where MNP has been used to some degree. So one of those options, an example of that is the kinds of choices people make about having children, for example, and how many to have, and some of those choices are planned and some aren't, but you can write that kind of thing down. In international relations, it's often the case that countries have to make choices among a set of alternatives to ally with one side or ally with the other side or do nothing. And again, we have a fair amount of data where we might try something of this kind. I've not seen anyone do that, but it's an instance in which that would work. And probably those of you listening to me are already thinking of 6 different things I haven't thought of. But the basic remark I want to make is, anytime people have to make choices among more than 2 alternatives, then a model like this, if you have enough observations, a model like this is potentially what you would want to do. And as Harold said, there are other models too. So it's one of the early ones was nested logit, for instance, where people make one decision and then there's a new fork where they could make another decision. That has been, again, that's the kind of thing that's been used in election research and could be used in other kinds of research too.
Okay, thank you.
Dr. Clarke, do you have any?
No, I think Chris has pretty well covered it. Whenever you, there are choices, of course. I was thinking of people in business and marketing, and that's their bread and butter. You're studying factors that affect the consumer choice and so forth. So there's an incredible amount of opportunities there. If you're someone, Carl, we had a couple of students in our class who are coming from the management school, and certainly models such as we're discussing this evening would be of great interest to them, and I'm sure their own professors over in the management school talk about these things. But if they don't, they certainly should. So
I have a suggestion too for following Chris and Harold suggest points. And imagine, like in Taiwan case, and the most debated topic is about energy choice. So so you can see, for example, based on Chris' suggestions, that you can choose between traditional energy versus alternative green energy. Then the government decided to scrape, for example, to fuel fossil-based energy production. Then you can choose different types of alternatives, such as natural gas for the time being, and then down the road develop more like a turbine, or these are the options, and then you can exactly use the MMP model to do some kind of estimation and to see how different people would choose different kinds of choices. And but this concept about nested choices are very interesting too. I think Chris mentioned a little bit. Can you talk a little bit more about nested logit and or the similar to that? I think Dr. Clarke mentioned about the mixed logit, but the nested logit is another concept that the students may be interested to. Yeah.
Why don't I say just a little bit about nested logit, and then because I have a little bit of experience with that, and then Harold can follow up with mixed logit, which I have not done. The case that I saw the most closely on nested logit was a former graduate student here who studied Northern Ireland. And there are 4 political parties in Northern Ireland, as many of you may know, 2 Catholic parties and 2 Protestant parties. And she initially began with multinomial logit with 4 cases, and it just nothing looked right. And so we talked about it, and it soon became clear that a nested model was what you wanted to do. To make a long story short, if you're Catholic, then you have 2 choices, and if you're Protestant, you have 2 other choices. But nobody really has all 4 choices. Nobody is doing that. There was a kind of briefly a kind of intermediate party. Could be another fork in the road, but that party has disappeared. And you don't have to be you don't have to be a believing Catholic or believing Protestant to be in this situation. Seamus Heaney, the Irish, the late Irish poet, I once attended a talk that he gave at the University of Michigan, and he said that someone he knew had gone to Northern Ireland, and they had said to get to know him, they said, "Well, are you Protestant or are you Catholic?" And he said, "Well, I'm an atheist. I'm not neither one." And they said, "Well, yes, of course you're an atheist, but are you a Catholic atheist or a Protestant atheist?" And we told that story in the book with Larry and I, and it just illustrates that identity is something that's different from what you believe. You know, you're just a member of a community, and you can't really escape that. So that was very evident in Mary Beth Altier, my former student's work, that the nesting was due to identity differences. So in situations in which there are, identities maybe not as strong as Catholic versus Protestant in Northern Ireland, but other kinds of identities, you can have a model in which people just split and would never consider, some set of other alternatives. That's what nested logic is designed to do. So people have used it to say, first you decide whether you're going to vote at all. That's the turnout case. And then you decide who you're going to vote for. I don't think that's the best application, because who you favor and how strongly you favor them has something to do with whether you're going to turn out. So I don't think that case really fits, but the Northern Ireland case did.
Yeah, you can see this as I might follow up with an example, a British example, the cleavage between Leavers and Remainers in contemporary British politics. It is, I think, a good example. On the Remain side, there are people who say, they would never vote for the Conservatives or for UKIP or successor party, but then amongst the Remain parties, they scatter their votes across, to some extent, Labour, but also the very vocal pro-Remain parties, such as the Greens, and if they're in Scotland, of course, the SNP or the Liberal Democrats across England. And so that's an example, a British example of that kind of phenomena right now. And you can see it in the data. It just jumps right out at you in terms of the kinds of choices that people made. And politicians are aware of this. And this, of course, was one of the reasons that Nigel Farage, who was the founder, one of the founders of UKIP, and then more recently the British Brexit Party, stood down in 317 constituencies where the Conservatives had won in 2017, because he was aware that this might happen, and they would, as they say, quite simply split their vote and might allow the Labour Party or perhaps the Lib Dems in the South to go up the middle, as they say. And so, yeah, the idea, this is often called, in some literatures, it's called the consideration set model. And so it's often applied in the continental European case, of course, to ideological families. You're either on the left, in France, I don't know how many are left. How many are left on the left? Maybe you could tell me, Chris, but historically, this would be an application. There's no way that I'm going to ever vote for a party on the right, but then amongst the parties on the left, there may be several choices, or vice versa. So this is a place where the nested logic model is attractive. But of course, the downside is what we talked about earlier tonight in terms of voting choice, that you pay a price for putting things in a hierarchy that you may not want to, in terms especially of interpreting some of the coefficients. We had a great example, quite a variable that's practically always in our model, education, is in our models, and you get a very different interpretation, as Chris showed us, depending upon whether or not you take account of turnout as one of the choices at the same level as the others.
Did I answer your question, Peter? You have follow-up questions?
Right, of course. And then it just reminds me of something, because for your information, in Taiwan, there's a referendum coming up in a week.
Yes,
So
yes, I can.
I think that's a very good. They will come up with good data. So that's a choice between 0 and 1. And if you want to, for example, one proposition is we have a nuclear plant and that's been dropped off years ago, and people try to, for this proposition is we want to reopen it or to reinstate this plant, and then there's quite a debate over these issues. So I think that would be a good example for us to use those multinomial models to study this issue. Yeah. Thank you.
Yeah, also a natural gas and part, right? That is
Yes.
another one. Whether you and there is an environmentalist and who opposed to the site, and but others who believes that natural gas is must do. Yeah.
Uh-huh.
Yeah.
So I
That
think
is.
the good, very good chance opportunity to study this one. Yeah.
Yeah.
Thank you. Yeah, sharing
Okay.
that.
All right. Now, 10 years, a really good question. And 10 years would like to bring it up yourself and conjoint analysis.
Definitely.
I like
Thank you,
that.
Dr. Ho. Oh, Dr. Achen, Dr. Clarke, I appreciate for your presentation. And I have a quick question for you from a marketing research perspective. Myself, I'm familiar with the analysis method called choice-based conjoint. I believe you're familiar.
Yeah.
How are the choice-based conjoint and the multinomial logic model similar or different or related, or they're just two completely different animals?
When you say conjoint, are you talking about the case in which there's been an experiment?
With attributes, with the levels.
Right, and you have a block design where different attributes occur in different cases. Okay.
Yes, Dr. Achen.
That's certainly a classic instance. The question would be, how many alternatives are there for choice? So if it's just two, for instance, you vote for the Democrat or you vote for the Republican, and or you prefer them, and typically in an experiment, turnout is not relevant. You're just asking for preference. That's just a vanilla Probit or vanilla logit problem. There's nothing that we would bring to this. When MNP would become relevant is if you're in a multi-party system and you're asking people with this set of candidates and this set of alternatives, which of these 3, 4, 5 parties would you choose? So then in that case you'd want MNP.
Mm-hmm. Mm-hmm.
Thank you, Dr. Achen.
Dr. Clarke, you want to add anything, or?
No, I think Chris is, as usual, right on the money with his response, and I really don't have much to but just simply to underscore this idea that these models we're talking about tonight are really become useful when we've got more than two choices. Otherwise, we're in a much simpler world, and but it's not a world that's typically confronts us. We typically have more than two choices. Even in the United States, as Chris has underlined tonight, we've got more than two choices. So.
All right, and let's see. I actually have a few more questions, but before I digress too much, and let me open to the floor, and also Taiwan and U.S. Any more questions for Dr. Achen and Dr. Clarke?
Not here for now.
Okay, yeah. Now, I think Dr. Achen and Dr. Clarke also bring up lots of new possible topics for future, and definitely more applications. And we look forward to seeing the new round of illustrations of the NMP and particularly for elections and also other applications. And also Dr. Clarke mentioned a few topics that is I think is particularly interesting to me, and which is the random regress minimization model, RRM, and also the other one is a finite fixture model, finite mixture model, which is looking into the even the probability distributions of different classes, and that is another thing that we can explore further in future. I know that we cannot do much tonight, but these are the really interesting new modeling strategies, particularly when you want to look into some classes we do not observe and explicitly, right, Dr. Clarke? Yeah.
Yeah, I think this methodology is quite useful, particularly now. We're in an era of extreme polarization, not just in the United States, but in a number of other countries. Yes. It seems quite natural to think that we would have multiple processes going on. And of course, the finite mixture model might be a finite mixture Probit model, not, the finite mixture model can be anything from a garden variety regression up through logit and Probit and so on. I've never seen a finite mixture MNP, but that would be, if Chris comes up with one of those. Exactly. The other thing I was just going to say, Carl, this is just sort of a practical thing now, we're sort of winding down, or an observation, is someone, I think you mentioned the impact of COVID, really sort of turning our world upside down in so many ways. And this is certainly true politically. And what we found in the American case was that, of course, COVID really hurt judgments about Trump's handling of COVID. Actually, controlling for all of the other usual suspects in our models, we found that was a very important consideration at the level of individual voting in 2020. Now, we didn't bring turnout in, but I certainly think it's relevant there. Now, in Canada, it was quite the opposite. Perceptions of government handling of the federal government handling of COVID were generally quite positive, and helped the Liberal Party didn't get a majority, but certainly helped them to get the plurality, the strong plurality that they did get. On the other hand, what COVID did to the economy, we argue hurt the governing party, so there are two very different scenarios there. And in Britain earlier this year, it was evident that the rollout of the vaccine, the successful rollout, an early rollout of the vaccine, certainly helped Boris Johnson and the Conservatives to head off what would seem to be an incipient rally by the Labour Party under their new leadership of Keir Starmer. And of course, the problem is, in the British case and elsewhere as well, of course, is COVID hasn't gone away. And so positive judgment, and there's some hint in the United States in the polling that this is hurting the Democrats and hurting Biden in particular, is that he made some pretty big promises about being able to take care of COVID. And of course, COVID is still with us. And so at least people who are doing public opinion polls are writing, for Real Clear Politics and 538 and so on, they're now writing these things that this is hurting. This is yet another one of the reasons why Biden's poll ratings are going down. So the politics of COVID is not over. It's sort of my final point here.
Yeah, that best another study by Chris and his team for the 2020 or even 22 elections.
This is just as depressing as our book.
I think even more so. I think more so. I think more so. No, yeah. This one of the, I might just say, one of the really interesting things about the book that Chris and Larry Bartels did, of course, is it raises this question, give it a fancy title, of what we call the psephological anthropology of the electorate. who are these people? Who are these people?
Yep.
And it's very easy to say, oh, they're these ultra, rational expectations guys, and they're all going to do this. But of course, we don't really believe that at all. And there's a huge literature now in experimental economics and cognitive psychology to back us up. The intuitions that people like the Four Horsemen at Michigan had in the 50s turn out to actually be a lot closer to the mark, I think, I would argue, than a lot of the very, stylized economic, rational economic kinds of approaches. And I think one of the great points about Chris's book is it really brings that out and gets us thinking about that again. And it's a key problem for scholars of voting behavior. Absolutely crucial.
Yeah. All right, before we wrap up, I think Tianyi and Julie and UTDSI has a question. I think it takes more time to address that question, but still I think both Chris and Harold addressed some, but I think we can quickly summarize this. And his question is, general question is, why should we even care about the election studies in the US, UK, and Taiwan? Why are they important? And what are they predicting and estimating? I think, can we briefly address this? Why studying these elections important? Why they're interesting? Yeah, Chris, what do you?
Well, elections determine who's in office. Biden's foreign policy is very different from, it has some overlap with Trump, but it's basically very different. It's much more cooperative with our allies. And
yeah, indeed.
And, from Taiwan's point of view, there's been a lot of evolution of American foreign policy toward Taiwan. This is something that didn't happen under Clinton, for example. So elections really matter.
Yeah.
And the United States is a big, important country, and so is Britain, and so we study those places. Taiwan's an interesting case. It's a possible flashpoint for World War III, so that makes it important. And Taiwan's domestic politics might be what sets off World War III, just like the assassination of the Archduke in Sarajevo set off World War I. So I think it's important to study it. The other thing I'll say about Taiwan is, if you want first-rate election data from the Asian democracies, you need to go to Taiwan. The other places are way behind on that. They are the East Asian standard for doing it right. And my colleague Nelson Polsby, when I was an assistant professor, I was at Berkeley, and he distinguished countries in the world where we have colleagues. He meant where there are serious political scientists who do good work, and the countries where, like, say, Russia, where we don't, for the most part. Well, Taiwan is a country where we have colleagues. They do terrific work, and so we use their data. We talk about their situation, and that's just a credit to them. They're serious.
Dr. Clarke, and you study.
I agree. I have very little to add to that. Who governs matters is sort of the very short answer that I would provide. But certainly in terms of quality, we're talking about data. About a decade ago now, I guess, Carl, we started visiting Taiwan, and I was very quickly impressed and very favorably impressed by the election study projects in Taiwan and public opinion polling more generally. And so, yeah, that's one of the places you can go and work with some really high quality data.
Indeed. Peter, I think you all three of us a very good beef noodle dinner.
Man. Serve you the best Peking duck next time you come.
Peking duck too.
I would be honored to attend.
Yes, me too. It'd be a distinct pleasure.
We we all say very good things about Taiwan, and then also Taiwan political scientist. Now we have one here, famous Professor Peter Pan.
Yes, thank you for saying that, and I'm really honored. So I think all of you have some experience here in Taiwan. There are, from my perspective, Taiwanese people, they're political animals here. So they're very good data, and then they have good sense of politics, whether it's for layman or academia. I think this is a very good place to study political science. I would say that. Yes.
Indeed, yeah. Democracy too, yeah.
Right.
Yeah.
Okay. So, is there any other questions, or Carl, you want to add any comments?
No, I think I will let you conclude. And
Okay.
it's about time, yeah.
Yeah. I think the time is up. It's 12 o'clock here in Taiwan. And then I want to thank you again for all of you to participate in today's event, and especially my thanks to Dr. Achen and Dr. Clarke. Thank you for making our season finale such a great supper. It's such a great talk and conversation. And then I want to appreciate everyone who has contributed to this colloquium. And looking forward to our next season, and hopefully we have enough money to to work on this project. Yeah, and I will try very hard to make it happen. Yeah, and
Yeah, wonderful.
Yeah,
Well, thank you very much, Carl. Thank you, Peter, and thank you, Chris. Wonderful talk. Thank you.
Yeah, thank you very
My
much.
thanks to all of you for the good questions, and my apologies when I missed my previous appointment after my surgery. I didn't handle that very well, but I'm delighted to be here this evening and to make it up to all of you.
You definitely made it up big time. You were very, very good. Thank you very much, Chris.
Thank you very much.
Yeah.
Yeah, thank you. Thank you.
So I think that would be all for now.
Okay, thank you.
Yeah, and please, looking forward to next season. Stay tuned, and then you can always check back to our website, Data Colloquium, Data Analytic Colloquium, and we have the previous clips and videos and all the I think either presentations, the slides, as long as all those speakers allows, and we will put on the website so for all your references. Thank you very much.
Thank you. Thank you.
Thank you.
Thank you, Peter, for organizing all this. Thank you.
Depending on where
Thank
you
you.
are.
Yeah.
Bye-bye, everyone.
Bye.
Have a
Thank
good winter break. Bye.
Yes, yes, for
Have a
sure.
very nice
Happy holidays.
holiday season. Good night.
Good night.
Good night.